Okay, so I'm going to be going over the semester final review for pre-AP chemistry. So first I just want to show you the format of the test. There will be 35 multiple choice questions, which you will get to write all over the paper, but you'll put your answers on a Scantron. And there will also be a free response part to the test, which just means open-ended and you're going to get partial credit for things. There are 13 questions, but some of those questions involve parts A, B, C, so it's not just 13 straight questions. You're going to get an equation sheet and a periodic table, and you're of course going to get to use a calculator. So the equation sheet you're going to get to use is not very long. That's all it has on it. So it has some prefix conversions, the percent error formula, and the Celsius to Kelvin temperature formula. So it's not that trying to hide things from you. That's pretty much the only conversions that you're going to need that you don't have to know just by knowing the things that we've learned for Avogadro's number and molar volume of a gas, the 22.4. Those things you just have to know. But these are included. You can write all over this equation sheet when you first get your test and write any notes to yourself that you want, but this is it. So the way that the semester test review is set up is you have one sheet that has the outline of all the different topics that the test will cover. And then on the back of that should be some extra problems. These were intended to be take-home problems for you to practice extra things that I'm not going to go over in class. But these are all worked and provided on course sites. So during this review, I'll be going over individual items from the outline, and then over on the other review that's longer and spaced out, those are where I'm going to work example problems. So I'll be switching back and forth between the outline and the semester review. So since this is such a long list of things, I'm going to break it apart and do this in 4 parts, where I cover a certain about 10 items on this outline for each video, so that you can find the ones that you need more of without scrolling through an hour and a half of video. So this one's going to just cover from 1 to 11, and we're going to talk about those, and then the next video will pick up on 12. Okay, so the topics that you have to know. As I go through this, if I don't spend very much time on the topic, it's probably not going to be emphasized much on the test. It'll be a minor detail. And if I spend a lot of time on something, it's probably weighted a little heavier. You need to pay attention more to it. So first one up, lab safety. That should be mostly common sense. You took a lab safety quiz earlier this semester. You read and signed a lab safety contract. Most of those are just common sense. Say that we wear goggles, we wear closed-toed shoes, we pour acid into water, we don't do things that are unauthorized. There's not really any examples on that. You can go back through and look at your lab safety quiz or contract if you still have that. Systems of measurements, that's just making sure you're aware that there are different systems. That we use the imperial system. In America, we use feet and pounds and things like that, ounces. But the rest of the world in science is not going to use those, but you're going to use the metric or the SI system, and so you're not going to see very many of those. You may see a Fahrenheit every now and then, but you're going to see grams and meters and liters, not the pounds and things we commonly use in America. So the SI prefixes I showed you on the equation sheet, that I am giving you 2 conversions, the one from the kilo and the milli. And so should have gone over this earlier this year, but realized that this is for the prefix kilo and the prefix milli, that you can replace this M with any unit you want. So there are 1,000 grams in a kilogram, and there are 1,000 milligrams in a gram. You can replace this meters part with any unit you want. It's just the prefix, the milli and the kilo prefix that we're looking at. So some other prefixes that you might have used that we'll use more next semester is a nanometer, or the nano prefix, and that's 1 times 10 to the 9th. Nano whatever equals 1 of that, whatever you've chosen. Okay. So that's the SI prefixes, just being able to use them in conversions, and you'll definitely see them as we work through some of these problems built in. Scientific notation. You're going to have to be able to convert from scientific notation back into standard notation. So that should be fairly easy. I don't have any particular on the one where we're going to work in class, other than just to pick one and show you. If I gave you this number right here and ask you to put it in scientific notation. Remember that we move the decimal place until we get a number between 1 and 10. So that would be 3.84. And then we do times 10 to the however many times we move that decimal place. So this guy would be to the 5th. Okay, and then conversely, if I gave you something like this, that's smaller than 1, we would still move the decimal place. Okay, but this one would be 6.2 times 10 to the negative 5th. Okay, the other thing some people get confused on this is if you get a number, okay, if that pops up in your calculator and it goes on forever, you're still just finding the decimal place. So if you put this in scientific notation, it would be 3.8246 times 10 to the 1st. You only had to move that decimal place once. So some people will ask me, well, do we really all need all those digits? Well, it depends on the significant figures that you're supposed to give in your answer. Maybe if you needed 5, sure. If you didn't, then you would have to cut it off at a different place. So being able to go back and forth, if you are doing a calculation, you may always put the answer in standard notation or in scientific notation unless I specifically ask for it. So either notation is fine and accepted equally. So carrying units through problems, that's essentially what we've been doing as the line all semester long. So we will we'll do several of these. Of course, you'll see the line all over the place, but if I just gave you something like this, just a setup here. Don't know why I changed colors there, but if you looked at this and I said, what are the units of the answer? This is a meaningless calculation, so don't worry about what it's doing. I'm just throwing units together. Just being able to, hey, the grams cancel, nothing else cancels, so I'm going to be left with moles on top, ATM on top, Kelvin on bottom, and joules on bottom. So even though that means nothing to you at all, it means nothing to me right now, I just made it up. Can you carry the units through and figure out whatever's left on top is on top, whatever's left on bottom is on bottom? Okay, the other thing to that is to remember that if you had something that was, let's say, 3.8 centimeters times 2.7 centimeters over 6.2 seconds, that if they're both on the top and they're the same unit, that we would put them together. So that'd be centimeters squared divided by seconds. So just being able to use units fluently, which I think that you're probably pretty good at now with doing a line all semester long. And you'll see over and over and over as we go through doing calculations and the units canceling out. Okay, we will get to work some problems pretty soon. So it's not just all me rambling on this, but the accuracy versus precision, that's simply a definition and understanding that. And the best way that I can demonstrate again is to use what you saw earlier in notes. If we had a dartboard and there's our bullseye, and someone threw 3 darts there, 3 darts there, and 3 darts like this. Okay, this person is not accurate, but they are precise. So precision is about repeating something, so they were able to repeat the same thing every time, but they just didn't hit where we wanted to hit. This person is accurate and precise. Sorry, this should have been just precise. Okay, and then this person is inaccurate and imprecise. You wouldn't want to play darts with this person. Okay, so accuracy is about being able to hit a specific target regardless of how many times. And precision is about being able to repeat something, regardless of whether it's where you wanted to hit or not. It's just about repeating it. So you're not going to be given dartboards necessarily, but what you'll be given is sets of data instead. So if I gave you that student 1 and student 2 collected a set of data, so let's say student 1 collected 4.58, 9.67, and 3.81. Those are 3 different gram measurements that they took in lab. and the second person collected 3.75, 3.71, and 3.73. And I told you that the goal thinged away, the goal answer was 4.59, and asked you about these two students. This one right here was accurate one time, but not precise at all. They weren't able to repeat anything. And this individual was able to repeat something, and I know you're bothered, but that's not exactly the same answer. But if you get those measurements in lab just simply off by hundredths, those are pretty darn close. This person is very precise, but at no point did they achieve accuracy, so they're not accurate. Okay. So if a third student came in and had 4.58, 4.60, and 4.59, they would be considered accurate and precise. They were able to get the target answer and also repeat that process. Okay, so just be able to understand, it'll maybe be one question, okay, but understand the difference in those terms. Okay, so next thing up is percent error. So you're going to be given the formula for percent error on your equation sheet. And this is the way it's written, so I do want to make sure that you're familiar with that notation. M is for the measured value. Okay, that is what you got. And then A is standing for the actual value. This is what you were supposed to get. Okay, and then you got to remember that these right here, absolute value bars, they're going to make whatever answer you have positive, so don't give a negative percent error. That would be ridiculous. Okay, so you just have to be able to use that formula. You would have to be given, since you're not going to the lab, you would have to be given an actual value and a measured value. You have one of these questions on your take-home review. It's, I believe, question number 3 to actually practice with this. Okay. All right, so now we're going to get into some things that we can do some calculations with, and we'll go to the in-class review. So significant figures, unit conversion, density, and temperature conversions are all things that we're going to practice with. So here's your in-class review. So question number 1 is find the number of significant figures in each of the following. So remember that if you're just counting in a number, every digit that's not a 0 always counts. 0 is the issue. So there are 3 places a 0 can be. It can be at the beginning of the number. It can be in the middle of the number, okay, of numbers that definitely count, or it can be at the end. Okay, so all of these are where 0 is. Okay, so if the 0 is at the beginning, never count it. If 0 is in the middle, always count it. Okay, and if 0 is at the end, sometimes count it if there is a decimal shown. So if you see a dot in that number, you're going to count zeros that are sitting at the end. So in number 1A, we have some zeros at the beginning. I'll try to color code these. Okay, and then we have a 0 at the end. So these zeros at the beginning do not count. This 0 at the end is going to count if there was a decimal point shown in the number, which there is. So then the 5, the 1, and the 0 are going to count. This one has 3. So B has 2 zeros at the end. There is no decimal point shown in the entire number. So this one is only going to count these 2 guys. Okay. C has a 0 at the end. There is a decimal point shown in the number. So they're all going to count. You're going to get 3. So that's purely counting. The things that you're looking for are the zeros. Then if you're doing some mathematical operations, you got to know the 2 rules. If it's multiplication or division, you're simply counting the least, the digits, the number that has the least amount of significant figures, you're using that number of digits. So for D, we're multiplying. We have 2 numbers shown, 87.6 has 3 significant figures and 2.4 has 2. You're going to choose the lower, so you're going to show your answer to 2 significant figures. Okay, it's not important necessarily that you multiply this, but if you did, your calculator would spit out 210.24, and you'd have to show just two significant figures, so that's what we'd show. That doesn't mean the number is 21. That means the number rounds to those 2 digits. We would give 210, and without that dot there, that 0 is not going to count. Okay, and then if it's addition and subtraction, the easiest way to think about this is like you were a little kid and you were lining up your addition. Okay, we would always line up the decimal points. So with adding or subtracting, you go ahead and add it. Okay, and then you would cut off the number after the column where, the last column where everybody has a number. So the last column that everyone had a number in was after the 10th place. So you can do that and give this number as 23.4, so there would be 3 sig figs. Okay, but the other thing, the quicker way to do it, instead of lining that up, is you're just looking at the places after the decimal. So 15.81 has 2 places after the decimal, and 7.6 has a single place after the decimal. So you would give the lower number of those, which is a single place after the decimal, which is what we did. Then you still have to count up the total number of digits. So with addition and subtraction, you cannot just look at the numbers given. You actually have to add it and then just cut it off at a certain decimal place. You can look at multiplication and division just at the numbers and say, I'm going to show something with 2. Okay, but because the numbers out front of the decimal could be any number of digits, you have to go ahead and add it. So then the hardest ones to do are, what if it's a combination of subtraction and division, or multiplication and addition, or anything like that? So then you have to follow order of operation. It's like doing 2 different significant figure problems. So this one right here has both on F, but the first thing to do, order of operation, says do the subtraction first. So if you do the subtraction first, and you do 13.5 minus 8.6, you're doing least number of decimal places. So you're going to give one number after the decimal. So this top is going to evaluate to 4.9, and then we're going to have to divide it by the 3.154. Well, now we're down to division, because we've handled the subtraction, and now we can count total number of sig figs. So this top number has 2, and the bottom number has 4, so we're going to choose the lesser. Okay, so the answer is going to end up having 2 decimal places, or 2 significant figures, I'm sorry. Okay. All right, so the next one up is unit conversions, just purely unit converting. So I gave you a couple prefix things on your sheet. I know you were given an entire conversion sheet earlier this year. You're not going to have to do that as much, because most of your conversions come now from grams to moles and moles to particles and all that kind of stuff. But just making sure you can do raw unit conversions. Remember, we are given a number to start with, and our job is to cancel out units with known conversions. And so the 2 known conversions that I think you would use, and some of you guys could do this in one, but most of us would know, okay, 1 hour is 60 minutes, and that 1 minute is 60 seconds. And so we would put the 1 hour on the bottom and its partner on the top, 60 minutes on the top. Okay, that's that first conversion. We use that guy. Hours cancels out, now we're at minutes. And we want to keep going until we're at the units that we want. So then we would put the 1 minute part on the bottom so that it cancels out and its partner on the top, 60 seconds. Minutes are going to cancel, and we're left with seconds. If we have the right units shown, then our answer is probably going to be correct, as long as we can multiply correctly in our calculators. Okay, so if you go ahead and do this, you should also pay attention to the number of significant figures that you give in your answer. So keep in mind, you're not going to use any of these conversions for significant figures, because I made up the sig figs. I could have written that as 60.0 or 60.00 or any number of zeros that counted. So I'm only going to use the numbers given to me in the problem for my significant figures. So I was given 2 significant figures. I need to show this answer to 2 significant figures. So if you take your answer in your calculator and round it to 2 significant figures, you should get 1.3 times 10 to the 5th. Okay, or again, you could always write this in standard notation and write it as 130,000. Okay, but the units need to be on there, and those zeros don't count if you don't put a decimal there. Okay, so that is just basic unit conversion. I know you've done a lot of unit conversion this year. Okay, so next up is density. So question number 3 is a little rough. It's got unit conversions in it. a little bit, and it's remember the density formula. So you got to know a little bit of math here. So you got to remember that the density formula is mass divided by volume. And so in this problem, you were given a mass, 39.4 grams. However, you were not given a volume. You were given the dimensions of some kind of sample, and it told you to assume the sample is a rectangular prism. Well, the thing we're missing in our density formula is volume. So we do have to know that the volume of a rectangular prism is length times width times height. So our volume should be 4.85, 3.81, and 2.64, all multiplied together. Okay, and if you do that, you'll get 48.78324. And you notice I just wrote down a bunch of digits. I'm not doing significant figures at all. Why I'm not doing that is this is not my final answer, and I don't want to round away my final answer. Some people can do this all in one step by calculating the volume in the middle of that formula. So we don't want a different answer whether you do it in multiple steps or in a single step. So I just kept everything right now, and I'm keeping it all in my calculator. The other thing is you have to know what your units are now, and so we multiplied a centimeters times a centimeters times a centimeters, so we should have centimeters cubed. So now we have our volume. Okay, we were given our mass. It asks us to calculate the density in grams per centimeter cubed, which nicely I have. Okay, so I can take my grams, my 39.4 grams, and put it over my centimeters cubed, which is the 48.78324. In no way is that significant figures. I'm using the significant figures given to me in the problem. So all those numbers that are highlighted in the problem, that's what I'm going with. Each one of those has 3. Okay, this number has 3, this number has 3, this number has 3, and this number has 3. So we're going to give 3 as in our answer. So I'm going to do 39.4 divided by that 48.7. And my answer is 0.808. And my units are grams per centimeter cubed. Both of those, because the units don't cancel here, and those are the units that I want. Okay, so that is density. It's basically just knowing grams per centimeter cubed or mass over volume. But even if you forget that formula, you could use the units in the problem to tell you what you're doing. I told you to do grams divided by centimeters cubed, so that's definitely mass on top. And centimeters cubed is a measure of volume, so we're going to put volume on bottom. Okay, and then temperature conversion. So you are given the Celsius to Kelvin temperature conversions. This one you're asked to convert 95.2 Fahrenheit to both Celsius and Kelvin. So you also need this conversion. Okay, or you can have that written a different way, solved for degrees Celsius instead. So if we were doing part A and converting to Celsius, we would plug in and we would solve for the degrees Celsius. So the first thing we would do algebraically would be to subtract that 32. Okay. And then we would get 63.2 equals 9/5 times the degrees Celsius. And then you divide by 9/5 or multiply by 5/9. Okay, so your degrees Celsius would be 35.1. Okay, so that's the answer to A. And then B says, can you convert this to Kelvin? Well, the Kelvin conversion is degrees Celsius plus 273. So we have our degrees Celsius now. We're just going to add 273 to it. So on B, we take Kelvin is 35.1 plus 273. Goes over. Okay. Okay, so you would get 308 Kelvin. And on these guys, these temperature conversions, we're not going to grade sig figs on the Fahrenheit to Celsius. We're not going to do that. I would just go with what you were given. This is mostly going to be multiple choice questions, so you just have to be able to convert that. Okay, so this is the end of 1 through 11 on the outline. The next video up will have 12 through 21. So